Okay, we are now in problem 7 on the trigonometry final review. These problems are going to look very similar to what's on the test. There's not going to be anything weird thrown in there. So this is straightforward. It actually gives you the function this time. Remember in the previous example it gave you the graph. You had to come up with this function. I really think that problem, problem 5, is more difficult. And hopefully you didn't think that was too difficult at all. This is even simpler. So the only thing I'm not crazy about is that it does give you a graph, and I'm going to give you the option if you want to just like graph it on some blank paper, go ahead and do that. And that way you can just like make the calls as to where these things are. Because this, you know my feelings about graphing trig functions this way. So let's move on. It's asking for the amplitude, the period, and the phase shift. Well, our method for doing that is we know these things. This is the same thing as a cosine. Cosine goes from 0 to 2 pi, so the secant goes from 0 to 2 pi. And when you're graphing a secant, what we really want to do is we simply want to graph a cosine, and then we'll kind of invert that cosine function. So let's go ahead and do that. So we're just going to pretend this is cosine, and we're going to say that cosine normally goes from 0 to 2 pi, and then we're simply going to solve for the x, and that will give us the number over here that we end up with is going to give us our phase shift, and the difference between this number and this number is our period. So that gets us all of that. We can go back and look at the amplitude when we're done. So let's subtract pi. And 2 pi minus pi is simply pi. I'm going to divide by 3. Okay. So our phase shift essentially is pi over 3 left. Okay, so phase shift. Down here we can just write that as period. What we have to do is take this number and subtract this number. So pi over 3 minus negative pi over 3 is the same thing as pi over 3 plus pi over 3, right? Okay, so we are going to phase shift in 2 pi over 3. Okay, so that essentially tells us the period. We can go ahead and write that in, 2 pi over 3. Now let's look at the amplitude. Looks like we're multiplying by -1. Well, that makes sense, except for the fact that we always take the absolute value, so the absolute value of -1 is simply +1. So our amplitude is still just 1. We need to remember this negative is here. When we go to graph this thing out, we want to make certain that that we take into account that negative is there, because our whole cosine function is going to be upside down. So let's go ahead, and I'm going to go ahead and graph on blank paper. And I would encourage you to do the same. It really makes things simpler. So what I'm going to do, I'm going to draw in my line. Remember, I only need one complete period. That's what it says, one complete period. So I know that I'm starting, according to what I calculated, at negative pi over 3. So what I'm going to do is I'm just going to make a declaration that that is negative pi over 3. Okay? Anybody that says different is just itching for a fight. And then we actually go all the way to pi over 3, so I'm going to go an equal distance over here. And this is going to be pi over 3. I'm also going to make equal distance here for my amplitude. I'm just going to call that 1 and -1. Now, cosine normally starts up, comes down, so I'm going to kind of draw in some light lines here. I'm going to start here. Now, halfway between here and here is where I'm going to come down, I'm going to cross, and then I'm going to hit here, and then I'm going to hit here, and I'm going to end up here. Okay? So, here we go. What is this halfway point? Well, if we just had to calculate it, it's essentially going to be half of pi over 3 or pi over 6. So if we had to, we could say that's pi over 6, negative pi over 6. And then we can kind of draw this in. This is the cosine. And, whoops, let's remember we got to do the negative. So if we're doing the negative, we're going to flip the whole thing upside down, which means we're actually going to start down here and end up over here. Okay. Now the next thing I'm going to do is I'm going to put in kind of a dotted line where we're 0, because now we're doing the secant function. And remember, if we know anything about the secant function, we know that at 0 the secant function basically has an asymptote. Okay, so this is what the secant function would look like. It would actually be equal here, and it would take off this way here, and this way here, and likewise this way here, this way here. And if you wanted to go out another, right, you could extend that. But this is actually a full period. Even though we're not starting at 0 and doing a full period, it's okay. That's a full period. You've got all the information you need. You don't need to be any fancier than that with it. And that's all there is. You're just graphing that. I like it on this, trying to translate these numbers, right? Negative pi over 3, where's that? And if you're trying to do an amplitude of 1, you'd have to pick some number here, you know, maybe 5 or 4 of these squares to be number 1. It just gets to be, you basically have to make all those declarations anyway. So I say, why bother? Let's just go ahead and do this. As long as you kind of keep things equidistant, you're going to be fine. And that's it. That's all you have to do for problem number 7.